Good morning. I'm Dr. Namratha Manohar, and this is my second episode. In my first episode of Computer for Programming for Beginners, I had put forth certain questions and queries. If you seek answers to the queries, you will be able to understand the particular programming language, history, and the fundamentals. So before applying those queries to C programming language, I thought we should first know the terms of certain words or some of the terms related to master the computer programming. So here I am presenting the terms of tips to master computer programming. Now, what you can know from this seminar, you will be able to understand the meaning, the purpose, and usage of certain important terms in computer programming. Now, the terms of the first level, that is preliminary information. Now, we all know that computer works on the binary system. That is, it has certain electronic devices, and all these devices we are in two states, on or off. So on is represented as 1, off as 0, or on is represented as true and off as false. So we should know what is the number system that can be supported by the computer processing. The number systems are decimal. We will see the decimal, what is the base of the system, what are the symbols in the system, and the example. Now, the decimal system, we know base is 10. The symbol used is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Example of a decimal number is 14. Now, binary system. Binary system base is 2 and the symbols used are 0 and 1. Say the decimal number 14 in binary form is represented as 1110. Now, octal. The base is 8. The symbols used are 0, 1, 2, 3, 4, 5, 6, 7. The decimal number 14 in octal form is 16. 1 and 6. Hexadecimal. The base is 16 and the base is 16 and the digits used are 0, 1, 2, 3, 4, 5, 6, 7 and A, B, C, D, E, F. A represent 10, B 11, C 12, D 13, E 14, F 15. Now decimal number 14 in hexadecimal. How is it represented in decimal form is E. So these are the number systems that are supported in computer programming or execution of computer program. Now, first let us see some aspects of data processing and transmission in computer systems. We know that in whatever form data is processed and transmitted in a computer system is a binary form. Since the electronic devices, as I told you, have two states, on and off, represented as 1 and 0 or true or false. Therefore, all the input data in whichever language you have written, whether you have written in C, Java, or Python, that it needs to be converted into zeros and ones. So this format of 0 and 1 is called machine level language. Now, there are two things: data processing, data transmission. Data processing. The two inputs to a computer are data and program. We need to enter the data and we need to write a program to process the data. So this program operates on the data which we have input to give you the resultant output. Both data and program are prepared by the user in English language, which is easily understood by the user. As I told you, English language, we have high-level languages like C, Java, all are high-level languages which are easily understood by the user, and the user can learn and write a program in that language. So data processing involves converting the high-level language into machine-level language to perform the operations given the program statements. The operations could be arithmetic operation, decision making, etc. as per the logic, and finally we get the output information in the high-level language to the user. Data transmission. Now, what is this data transmission? After we have entered or processed the data using the program, we need to transmit the data. So, data transmission is a process of moving data from one digital device to another. This transmission again is done in zeros and ones, and the 0 and 1 are called bits. This can be done via point-to-point data stream or channels, which can be copper wire or wireless networks. Now, what is the unit of data processing and transmission in the computer system? The fundamental unit is bit. Bit means either 0 or 1. Now, since the data is very long and we just cannot keep on saying 0, 1, 1, 0 like that, we have a unit called byte. Byte is made of 8 bits. It is used in determining the system storage. So that means we have a system storage for 1 bit, or 8 bits will be 1 byte. Byte is the most common term used in computing. Each character, say A, X, G, F, any character that is represented by a byte. So this character, which is represented by a byte, is called the ASCII character, ASCII code. So the conversion chart of bit is, if we have many bits, that is 8 bits we know is 1 byte. But 1024 bytes make 1 kilobyte. And 1024 kilobytes make 1 megabyte. And 1024 megabytes make 1 gigabyte. And 1024 gigabytes make 1 terabyte. Now, what are the preliminary information terms that we need to know? Front-end software. What is this front-end software? Front-end software is the screen that a common user sees. Say you have gone to an ATM, and once you go to an ATM, on the screen you will say, welcome. So, and then it will ask you to insert the card. After inserting your ATM card, then it will ask you, there will be some options on the screen. So these options, what you see on the screen, is called or developed by the front-end software. So front-end software enables to develop user screen, which may contain buttons, checkboxes, graphics, and text messages. So it allows your user to interact with your applications. That is the screen you see on the ATM machine, which says insert your card. This screen is called front-end software. Now, what is back-end software? It is a program that makes your application work. So it stores and processes the application data entered by the user. Now, here, whatever data you have entered, say you have asked, at the ATM machine, it will ask you whether you want to credit money or you want to draw money or withdraw cash or you want a receipt. So these queries, whatever you have entered the option there, this option is taken by the backend software and processed, and it gives you the ultimate result. Say you want to withdraw cash, it asks you how much of cash you want, and then it processes and gives you the amount of cash. Now, version, it is a specific iteration or release of a software program or application denoted by a numerical or alphanumeric identifier. Say C language versions are, it started from B, then C, 89, and there are many more versions. Presently, we have ANSI C or ISO C. Now, what is the source code? Source code, or we call it as a program, is written in the high-level language as C and Java. Object code, the code in machine language or binary language. This object code is an executable language. So this high-level language needs to be converted to this object code. Now, compiler, the software that converts the source code to the object code before the program runs. It's called the compiler. So this compiler converts the high-level language to machine-level language. So it translates the entire source code at once and saves it as a file before executing it. So suppose you have written a program of 10 lines, all the 10 lines are converted. First, they are checked for any errors, say syntax errors. And if there is all these errors are checked, and after the entire file is checked, then the final list of errors is displayed for correction. So after the errors are corrected, only the software can be executed. So in the compiler, all the lines are compiled at the same time. That is, you get the errors that are there in the program after compiling the entire file. So here we have C, C++, which are compiler based and are faster than interpreters. Now, what is an interpreter? Here, interpreter also translates high-level language to machine-level language, but line by line. Say we had a language called BASIC, Beginner's All-Purpose Symbolic Instruction Code, which is an interpreter-based language. That is, say once you have written the code of 10 lines, first line is checked. If there is any error in that line, it displays the error. Unless you correct the error in the first line, then only it will check the second line. Again, after checking the second line, it will display the errors in that line. After correcting the errors in the second line, then only it goes to the third line. So in this way, line by line, it is checked, verified, and interpreted. So that is why we have basic JavaScript, which are interpreter-based languages. Since it goes line by line, interpreter is slightly slower than a compiler. Now, what is command-oriented? It is a type of interface where users control a software or system by issuing specific text-based command at the command prompt. Example, Unix shell, Microsoft Windows command are all command prompt. That is, you will have a command prompt. If you see the screen, you will have a command prompt. If you see the screen, you will have a command prompt like if it is DOS, you'll see a command prompt like this, wherein here you have to enter your code, or you have to enter your instruction. Say you want to see the directory, what all files are in the directory. At this command prompt, you type dir. Then it will display all the list of files in that particular directory. So this is called as a command prompt. So here we have Unix shell, Microsoft Windows command prompt, SQL. These are all command prompt based. In SQL also, we write statements such as select, insert. Now, menu driven. A menu interface where users interact with the program or system through a series of menus. So here the user need not know any programming. He will just click on the button and then use that particular facility provided in the button. Say he presses file, it will give you options such as file, new, save as. So using those menus, you can create that. So we have this Microsoft Word, then PPT. These are all menu-driven softwares. Now, we will see some more terms. That is procedural language. A procedural language that uses a step-by-step approach to solve a problem. So here we have C, Basic, Fortran, and Pascal. Here the program is written in the form of a procedure, sequence of steps. Now, object-oriented. In object-oriented programming, it's a programming model that organizes software design around data or objects rather than functions and logic. For example, book is treated as an object. and because book has the attributes as title, author, etc. Now, what is a free-form language? Free-form language, the programming language where the position of the characters on the editor is not important. We know that every software has an editor, that you have to type your program on the editor. So in that editor, in the form of free-form language, say this is your editor. In the editor, you can type anywhere. It does not matter, but the sequence of the statement should be in order. Case sensitive. Case sensitive language is a programming language that differentiates between uppercase and lowercase. Say small and written as with small letters A and D, and written with capital letters A and D are different. So they are called case sensitive languages. Now, program structure. Now, how do we write the program? The sequence of step in which the code is to be written on the editor of a particular language is called as a program structure. So, the sequence varies from one language to another. To another. So, in C, we have, if you can see here, in C, this is the program structure of C language. In C language, first we have the documentation section, preprocessor directive section, definition section, global declaration section, then the main function, start of the main function, the body of the main function, closing of the main function, and then you may have some user-defined functions here. This is for the C language. In the documentation section, you will give only comment statements such as name of the program, date of program, the purpose of the program. In the preprocessor directive, you will be invoking some library files or what is called as header files in C. In the definition section, you will define some constants, global constants. In global declaration section, you will be giving some of the global functions which can be used by a set of programs. This is the main program wherein you write your logic of the program. Now, while we are converting from high-level language to middle-level language, a number of files will be created in the process. So every program written in a high-level language should be compiled, interpreted to eliminate errors and convert to machine-level language. So during this process, several files are created and they have extension as .obj or .exe. However, the final file is .exe. So if you have only this .exe file, it is enough for you to run a particular program. Now, the creation and compilation and execution of C program, we will just have a look here. This is the source program which is written in the C language. Now, after it is compiled by the compiler, then you get what is called as an object file. The extension of the object file is .obj. Now, this object file is then linked. Linking is, as we said, we have some inbuilt functions. Say you want to use sine, cos, tan, then you may be invoking man.h header file. So the files will be linked to your program. After linking, you will get what is called as an executable file which has extension .exe. On executing this file, on the processor, you will be getting your resultant output. Now here, these are the keys, Alt plus F9 for compiling you have, and then you have Control plus F9 for compiling. Otherwise, also C is again a menu driven editor. So you just click on the menu execute, then you get a drop down menu, and then you can click on compile and then go to your user screens to see your output. Now, what are the important features of the programming language? in the first episode, I had told you that every program in language should have what is called as modularity, reusability, extendability, platform independence, maintenance free, and security. So what is this modularity? Module, we know, is a small block, right? Now, module is a software design technique that involves dividing a computer program into separate modules. So each module will have a specific function. Modularity makes software easier to design, develop, test, and maintain. Now, to process the results of the students in a class, we can write modules. That is, you write a program to enter the data. That is one program. Then you write a program to compute the total, average, and rank of each students. Then you write a program for printing the results. Now, the advantage of having these separate files is, suppose in any one of the input changes, that is data. Say previously you had only marks in 3 subjects, but now you want to make marks in 5 subjects and you want to increase the number of students, then only this particular program need to be modified. That is, enter the data file need to be modified. Now, for the second program is computing your total average rank of each student. Now, again, here also, suppose you want to introduce any other aspect, you can write a code to that particular aspect so that this particular module of entering the data and printing does not change. So, modularity gives us some flexibility and also supports reusability and extendability. Now, what is reusability? Reusability is the use of a particular program for another application with slight modifications, right? So with slight modification, you can use it in another application. So modularity makes reusability easy. So you write a program for a particular school, class result analysis, then you can use it for another school also by making slight modifications. That is called as reusability. Next, extendability. Now, software is the most fast changing product. So now today your requirement is something, but tomorrow your requirement changes. So you should be able to extend your program. So extendability is being able to add more functionality to the existing computer program. You have a program to evaluate the performance of an employee in a year. Now you want to compare the performance of the employees of the particular cadre quarterly. Then you can extend by adding more code lines. Now, what is platform independence? Platform independence is the ability of being able to run the program on multiple operating systems or hardware platforms without significant adjustments. We know that we have different types of operating systems. So, once you develop a program in one type of operating system or hardware, you should feel free to run it on another operating system or hardware. So Java is one type of language which is platform independent. So Java programs are compiled into bytecode. Java programs are compiled into bytecode, which has a feature write once, run anywhere methodology, allowing the same program to run on different machines without modifications. Maintenance. Every programming, you might think, what is maintenance? When it's just a software, why do we need to maintain? As I told you, software is the most fast changing product. Our requirement keeps changing almost day by day or hour to hour. Once you start using the software, you will begin to think, I wish it could give this output to me. So that is why we need to have maintenance. Maintenance is the process of keeping a computer program up to date, suiting to our changing requirements after it's been developed. So it involves a number of activities such as fixing errors, finding and fixing bugs in the program, any errors, adding new features or functions to the program, updating your documentation, that is keeping the program's documentation up to date. Remove code. Remove unnecessary parts of the program code so that it reduces your execution time. Next, testing. You need to keep regularly testing the program to find any errors. Now, as I've already mentioned in my first video, that is my experiences, why an engineer, though he is an engineer, any engineer should learn computer programming. So during my services as deputy manager at Hindustan Cables Limited, I had maintained the production planning and control, right? Software files as periodically with changing requirements of the customers. That is, the customers keep changing the product specification. So when the customer changes, the product specification also changes. And obviously, the reports required also changes. So because of this continuous change of this customer requirement and product specification, we need to modify the programs. So that is why maintenance of the computer program is required. So in the previous episode, I had highlighted that this aspect in my first video on importance of programming for electrical engineers. You may please watch this also, why it is required that every engineer, whatever branch he may be, should learn computer programming. Now, security. We always hear of theft, computer cyber security. As a common term, you have heard of cyber security. So our software also is subjected to cyber threats. So computer security is required, or what we call as digital security or information technology security is the protection of the computer software system and network from threats that may result in unauthorized information disclosure, theft of or damage to hardware, software, or data, as well as from the disruption. We can protect by using softwares as antivirus, firewalls, etc. So, say common thing we hear every day in the news is certain people have lost their funds due to hacking. So that is why all computer programming should be secured. Now, program code building blocks. Now here we will see with certain examples. Now, first we need to see what is the character set. Every language has its own character. These building blocks are unique to every programming language. So we need to study for that particular language, what are these aspects? What are these aspects? So character, a collection of characters, that is letters A to Z, capital A to Z, small a to Z, numbers 0 to 9, punctuation marks, symbols using which program is written. Every language has its own character set. So here we have, you are seeing the small m, you are seeing the number 10, here you are seeing 5x. So what we should use, how we should use this will be defined in the instruction chapters of that programming language. Now, data type, a term that specifies the type of data. This enables to handle the data, assign memory space for effective management of memory and transmission speed. So here, what is the data type? Here you are saying the data type as int. Int means I have taken a variable called x or a constant called x. So here I am assigning the value 5. So that 5 is an integer. So now if I want to store it as 5.5, I need to declare it as float. I need to declare it as float. And if it is a character, say A, B, C, D, I should declare it as a char, C-H-A-R in C language. So in this way, we have various types of data types in every particular language. Now, when you specify this int, how much of memory space each integer is occupies in the memory space once you declare this. So once you declare this int x is equal to 5, right? So that means this is a variable called x. This is a variable called x. You are assigning the value 5 to it and its type is integer. So once you declare this, some amount of memory space is reserved for this variable. Why we need to reserve the memory space? So it is like allocating seats in a bus. Say you're traveling somewhere, once you have booked your ticket, your seat is reserved in the bus. right? So once the particular seat is reserved, we will know how many passengers can travel in that particular bus. So in this way, same way, if you want to use your memory effectively, you need to know how much memory space need to be reserved for a particular variable, constant, or term. So integer data type store only integers, string a character, set of characters as hello. In C language, each of these alphabet is called a character and a group is called as a string. And string in C language is given within quotes. Keyword. Keyword or reserved word are predefined tokens in a programming language that have special meanings and purpose. So these words are reserved by the language for a particular purpose or meaning only. You should use that word only for that particular purpose. Example, in C, C has 32 keywords, if, else, int. Now, this is a C language, so we have words called include, stdio, int, then you have main, you have void, you have main, you have void, int, then here if you come down printf, all these are keywords. Constant. We have two types of data types, constants and variables. A constant value that remains the same throughout the program execution. Now we know that pi, the value pi in mathematics has the value, pi has 3.14. You cannot change it. So you can make it, declare it as a constant. Pi is equal to 3.14. This is float. So you fix the value as 3.14. And you can also keep it. Suppose you're using this pi in 3 or 4 programs, you can make it as a global variable. Float pi is equal to 3.14 as a global variable. Now, variable. A variable is a value that can change during program execution. It represents an unknown value. Say in a program, you want to add 2 numbers, but the numbers will be entered as and when required during execution. So you keep it as a variable. So here we have declared 2 constants. So 2 constants. One is, this is a global variable. You can see this is a global variable. Then the one that declare in the main, this is called as a local variable or local constant. X is equal to 5. That's the constant. Now coming to int z. Coming to int z, I have not given any value here. That means it is a variable. X is a constant, z is a variable. So z needs to be accepted at the time of execution from the user. Global variable, I have explained to you what it is, and local variable, I have explained to you what it is. Now we'll see some more. What are the types of statements? We need to know what are the statements that can be used in a particular language, right? Now, we have what is called as assignment statement, control statements, input statements, output statements, arithmetic statements. These are some of the types of statements, but in every language, they have their own, it has its own set of statements. Now, assignment statement, but these types of statement will definitely be there in all languages. Assigning a value to a data type. For example, int x is equal to 5. That is, I am assigning the value 5 to x. This is an assignment statement. Control statement. This is to control the logic of execution. These control statements are decision-making statement, looping and branching. Decision-making. That is, if x is less than 5, then I am saying y should less than 5, y should be 10. So I'm taking a decision here. X is less than 5, y is equal to 10. Looping. Say you want to do the same operation again and again. You want to add 10 numbers. You need not tell, say, sum is equal to a plus b, sum is equal to a plus c. You need not keep on repeating that set of lines, but you can put it in a for loop. For I is equal to 1, I less than I plus plus, printf I is equal to percentage d I. So the output here, I'm saying initially I is 1. So it will print I as 1. Then I am saying, what am I saying? I plus plus. So I is incremented to 2. It becomes 2. But it is less than 10. So it will print 2. Then I is incremented to 3 because of I plus plus. 3 is still less than 10. Then it will print 3. So in this way, it keeps on going up to 9. 9 is less than 10. So it prints 9. But if I increment 9, I will get 10. But 10 is not less than 10. It is equal to 10. So then this loop stops. Next is branching. So if m is equal to 5, go to read. That is, I have a set of lines, but the logic for a particular decision lies somewhere in some other part of the program. Then we can use branching. Input statement. That is, to accept data from the user, we have what is called as input statements. C has what is called as scanf function. Here I am accepting the age from the user. Output statements. To display the final result, we get the output statements. In C, we have what is called as printf. Then arithmetic statements to perform arithmetic operations such as addition, subtraction, multiplication, division. So these are some of the most important types of statements commonly used in all programming languages. Now, we will see what are the list of operators. Now, in the arithmetic to take a decision or to perform arithmetic operations, we need the operators. So, what are the operators? We have arithmetic operators, relational operators, logical operators, assignment operators, increment and decrement operators, bitwise operators, ternary operators, if-else, and these are the operations. So every language has its own set of operators. We should know the correct syntax. We should know the correct syntax of that their usage and the operator precedence. Arithmetic operators used in C languages are add, plus, minus, addition, subtraction, multiplication, division, and modulus. Here we have what is called as modulus or slash, so that we know that right. Now, relational operators. Double equal to, not equal to, less than, greater than, less than or equal to, greater than, equal to. That is, if x is less than y, then z is equal to x plus 10. So this is the relational operator, or you can, this, as we have seen, this is the decision making operator. Next, logical operators, and, or, and, not. So if x is greater than 5 and x is less than 10, that is, if x is between 5 and 10, that is, if x is 6, 7, 8 or 9, then we are saying m is equal to x into y. Now, assignment operators. Assignment operators are equal to, plus equal to, minus equal to, multiplication. Then what are these? These are all called shorthand operators in C, right? So if int x is equal to 9, instead of writing again x is equal to x plus 3, say you want to add 3 to x. Instead of saying x is equal to x plus 3, we can write as x plus is equal to 3. We can just write x plus is equal to 3. So this is equal to x is equal to x plus 3. This is called shorthand operator. Now, increment and decrement operators. Now, we need not, each time you want to increment a value, you need not write, say, x is equal to x plus 1, but you can just say x plus plus. Say we have a variable a, we have x as 5, and a is equal to, we have given the expression a is equal to 2 into plus plus x. So, since we are giving plus plus x here, plus plus x means x is 5, so x is incremented to 6 and 6 is multiplied by 2 to give you 12. But suppose this is called as pre-increment. You can also have post-increment. Here we have given after x is as plus plus. So here what is there? X is already 6 here, 5 here. So 5 into 2, 10. The output is 10. Now, after this, in the next equation or the next statement, what is the value of x? X value of x will be 6. That is, after using in this particular expression, then x is incremented to 6. Then we have bitwise operators, right? That is, each bit can be shifted and or not or tilde, complement. Say you have the P and Q with this binary values, then P and Q. So here you do the AND operation of P and Q. This is all operation of P and Q. This is not operation of P and Q, and this is not operation of P and Q. So all zeros here complement value of P. 0, 0 has become 1, 1, 1 has become 0, 1, 1 has become 0 here. So this is the complement of P. Next, C has a special operator called ternary operator, which is equal to if-else statement. So here we have just an example. I have the cost, I have discount and a price. Now, if my price is greater than 60, then the cost I'm giving 10% discount, right? And otherwise, I'm giving 5% discount if it is less than 60. But since our price, so I'm writing discount is equal to if price is greater than 60, question marks, cost is equal to price into 1.1, cost is equal to price into 1.05. This is how the if else statement is used. That is, this is a short for if and else loop. Now, similarly, we have what is called as expressions and evaluations. And expression is evaluated based on the operator precedence and associativity. Just as in maths, we have board marks. Now, decision-making structures. These are structures which enable us to take a decision. That is, if the expression is true, you can take a decision, and if it is false, you take another decision. For example, if x is less than 5, if x is less than 5, that is, if x is less than 5 is true, right? Then a is equal to a into 6. Now, if x is less than 5 is false, then a is equal to a into 9. Looping, as I told you, to repeat a particular operation again and again. Branching, to go to a particular point in the programming. Here in C we have what is called as go-to statement. Functions. A function is a set of statements that when called perform some specific task. They are the basic building blocks of a programming language that provide modularity, code usability. Now, C has what is called as two types of functions, built-in functions and user-defined functions. Built-in functions are stored in the language library. In C, we call it as header files. So by invoking these header files, we can use these functions. For example, in C, we have a header file called mat.h. By invoking this mat.h, we can use the mathematical and trigonometric functions, sine, cos, tan, we can use. Now, user-defined functions, apart from the regular functions, a user may want to write his own function. Then he can create his own user-defined function. Say, for example, in your program, you're frequently using the factorial of a number. Then you write a particular code for the factorial of a particular number and store it as a function and keep using this function instead of writing this entire code again and again. Now, memory management. One of the most important resources of computer program is memory. So we need to manage the memory because, as I told you, every data type has its own memory space. So you should select the right data type. Then by using the optimum number of programming statements, if you keep on writing many program statements, you will be occupying more memory space, and then the compiling or interpretation time and execution time will be too long. So that is why we need to know how to manage this memory. So planning your data and program is very important. Now, file management. Data and program are all stored in the form of files. So these are called, this is called file management. You should be able to manage your file. That is, plan what are the types of files you will be creating for your particulars. So this is a few concepts before we go into applying the queries which I have given in my previous episode to C language. So thanking you. Any further queries, you can always contact me on my mail ID jnm7064@gmail.com. Please don't forget to like and subscribe to the channel. Thank you. These are the character sets, letters, character set, upper digital, white spaces, special for C, data types of C, and have given. Thank you.